All right, 7th grade, are you ready for this? We are going to multiply some binomials. Yeah, all right. Binomials, you may or may not recall. Binomial, bi meaning two, nomial names or terms. So a binomial looks like something like x plus 4 has got two terms, an x term and a plus 4 term. Or a binomial could be something like 2a minus 3. Two things stuck together to make a binomial. And we are going to multiply them, all right? There are three different ways that you can use to multiply binomials. And it's totally up to you which way you want to use, even though the third way is the best. But that's up for you to decide, all right? We are going to talk about a way to multiply x minus 1 times x plus 3, all right? And we're going to do that three different ways. One way is called stacking them up. Second way is called using a lattice. And the third way is FOIL, all right? Now let's be clear on this, all right? It's not just x times x is x squared and minus 1 times 3 is minus 3 and the answer is x squared minus 3. No, no, no. Really, you know, what we're talking about here is double distributive property. I've got to take everything here times everything there. I got to do this times that and that times that, and I got to do this times that and that times that, and then combine any like terms. And in fact, some people actually do it this way, but I'm not even going to go there, all right? So let's talk about three ways to multiply x minus 1 and x plus 3, two binomials, all right? The stack 'em up method, as you might suspect, just simply means we're going to stack one binomial on top of another binomial. And I'm not going to put a time sign there because then it would look really crazy because we got all these x's, right? But understand that I'm multiplying, all right? And what I'm doing here is I'm taking this term, all right, plus 3, and I'm going to multiply it times each of the other two terms here, all right? So I'm going to do plus 3 times minus 1. 3 times minus 1 is minus 3. With me so far? Okay. Then I have to multiply this term, plus 3, times the next term, times x. 3 times x. 3x. So I've taken 3 times x and times minus 1, and now I've got 3x minus 3. All right? Now I've got to do the same thing with the next term. I'm going to take x and multiply it times minus 1. And just like in stacking it up in multiplying numbers, I'm going to indent and leave a space under the 3 because x times minus 1 is minus x. And notice I'm keeping the like terms on top of each other. And then I take this x times that x. X times x is x squared. And now I have two partial products. I mean, if this was 31 times 43, the exact same thing would be happening here, right? 3 times 1 is 3. 3 times 3 is 9. Indent. 4 times 1 is 4. 4 times 3 is 12. And then I'd have two partial products. And just like this, I'm going to add them together. I'm going to do the same thing here. I'm going to add them together. And I've got a minus 3 that just drops down. It's not combined with anything. Now I'm combining like terms. Remember, like terms have to be the same variable to the same power. I got 3 of these x's. I take one of those x's away, and I'm left with plus 2 x's. All right? Everybody see that? The plus signs and the minus signs are important. They separate the terms. So you got to keep them in play here. And then I just got this x squared here, which just kind of drops straight down and becomes x squared. And that's the answer. X squared plus 2x minus 3 is the solution to x minus 1 times x plus 3. And I've taken them written like this and just stacked them on top of each other. Then I've got two partial products, combine the like terms of the partial products, and I end up with the answer. All right? Just like here, exactly the same way. I'm just doing the same things. All right? And notice that, I mean, here I'm keeping the digits are in the same place value. Here, I'm keeping the like terms in the same column so that I can combine. Very similar this with numbers, all right? All right, so let's try x plus 2 times x minus 6. And you'll see it, x plus 2 parentheses x minus 6, all right? That's the way it looks in the book or on a test or homework or whatever, all right? And if you prefer the stack it up method, then you have to take this and rewrite it as stacked up. So that now I do minus 6 times 2, minus 12, and minus 6 times x, minus 6x. Remember, the plus or minus signs always go with what follows. Then I take the x, and I take x times plus 2, that's plus 2x. Remember, I'm keeping like terms on top of like terms, x times plus 2 plus 2x, all right? And then x times x gives me this x squared. Now I combine the like terms. X squared, 2x minus 6x is minus 4x. And the minus 12 drops right down, and there's the answer. So that's how you stack it up, all right? Again, this times this, and then that times that, keeping everything in correct like term order. All right? So if you like to do that, you can do it, all right? But here's another way. The idea of a lattice. We go back to our original problem, x minus 1 times x plus 3. In this case, we're going to make a box, and we're going to divide this box into squares, and each of these columns and rows is going to get one term. So I can, it doesn't really matter which goes where, but I'll say this is two terms, right? X and minus 1. So I'll put this x here and minus 1 there. X has its own column, minus 1 has its own column. And I'll do the same thing with rows over here, x and plus 3. All right? And again, I'm paying attention to the plus and minus signs. And now it simply becomes like lattice multiplication. I fill in the boxes by multiplying the two things. So I can do x times x, that fills in this box with x squared, right? X times x. And then I can do x times plus 3, that's plus 3x, right? And I can do minus 1 times x, that's minus 1x. And I can do minus 1 times 3, that's minus 3. All right, so I got the boxes filled in. Now, you might notice that the diagonal here are like terms. They can be combined. And so now I can write the answer by starting with x squared, combine this, 3x minus 1x, leave me plus 2x, and then minus 3 is just by itself, not combined with anything, minus 3, and there's your answer. All right. This has the advantage of maybe it's a little bit neater. The diagonals, this box and this box, will always combine. This box will be by itself and that box will be by itself. All right. So you've got this nice pattern you can follow. All right. Let's try with a different problem. X minus 4 times x minus 2. So I build my lattice, make a box, columns, rows. All right. X minus 4, x minus 2. All right. Build it in like that. I'm just breaking them apart. All right. It's the same thing. Just remembering that the minus sign or the plus signs go with what follows. Then I fill in the box, x times x, x squared, minus 4 times x, minus 4x, minus 4 times minus 2, plus 8, and x times minus 2, minus 2x. So I see these are like terms. I've got an x squared and I've got a plus 8. So I can write x squared minus 4x and minus 2x more is minus 6x, and then plus 8 brings it all together, and there's your answer. All right? Remember, minus and more minus makes even more minus. There's no canceling out with the minuses. They're the same sign, so you get more of them. And the exponent, when we combine, never changes. This doesn't become x squared somehow. It's an x and another x, and it stays x, please. So you get that. It's your final answer. All right? You with me so far? Now, for something called FOIL. all right? FOIL is the ultimate way that you should strive to do these types of things eventually. Right now, it doesn't matter. You try them all out, see what you like, all right? But FOIL, as you might suspect, is an acronym. It stands for first, outer, inner, last. And that's talking about these terms here, all right? We talk about first, all right, F. It's just a way to remember the procedure here, all right? We do first means first term times first term. So I've got here, that's the first term in this binomial, times the first term in this binomial. There's F, all right? And we see that x times x, first times first, we knew that in our head, that's x squared, right? All right? Then it's got outer. So we look at this as one big problem, and we see that there are two terms that are the outer terms, all right? You got x, and you got plus 1. That's O for outer. These are the two outer ones, all right? Remember first, outer. So now I multiply the outer terms, x times plus 1, and I get plus 1x. So here's first, outer, all right? Then I stands for inner. This term and this term, that's the inner terms, the ones closest together, all right? Minus 3 times x, minus 3x, and that's the I in FOIL. And then finally, L, last, is the last term here times the last term there. Minus 3 times 1, minus 3. That's last. First, the product, all right? The answer you get when you multiply first times first. Outer, the answer you get when you multiply the two outside ones. Inner, the answer you get when you multiply the two inner ones. And finally, last, the answer you get when you multiply the last in this binomial times the last in that binomial, and you get minus 3. And you will notice that outer and inner are like terms. Minus 1x, minus 3x. And so they should be combined. Otherwise, this is NST. So we can say x squared plus 1 minus 3 minus 2x minus 3. And there you have it. There's the answer. All right. Now the advantage of FOIL is that eventually you do this enough, you'll be able to do this in your head. Because first times first is going to be easy. That's going to be x squared. And last times last is just a number times a number. But the trick will be to combine outer and inner in your head. So you get 1x minus 3x. Can you do minus 3 combined with 1? Minus 2. And that's where the minus 2x comes in. Because outer and inner will be like terms. And they can be combined. All right? Let's try it again. Let's look at foiling this. All right? We look at first times first. All right? X times x, x squared. Outer, x times minus 2. All right? I can write it down. Right? Minus 2x. Inner, minus 2 times x, minus 2x. And last, minus 2 times minus 2 is plus 4. Minus times minus now does make plus. But here, minus 2 combined with minus 2 doesn't make plus 4, and it doesn't make 0. It makes more minuses. So the final answer, x squared minus 4x plus 4. Alright, let's try that again. Let's do one more FOIL here. And this time, try it in our heads. Alright, so that we have something like x minus 2, x plus 3. Alright, so first times first, I'm going to write x squared. I could just go ahead and write last times last immediately, minus 2 times 3. We know it's going to end in minus 6. And now I'm thinking, alright, outer plus 3x, inner minus 2x, plus 3 minus 2 just makes a plus x. Oh, there's the answer. Didn't have to write the two terms because I could combine them in my head. I would start by going and writing the two outer inner terms down, but as you get better at this, you're going to find that just looking at it and writing the answer is definitely possible. All right. All right, so what good is this? Well, now we can start to do algebraic geometry. We can talk about a rectangle that is x plus 10 feet long and has a width of x plus 1 feet. And the question is, what's the area? Well, the area is equal to the length times the width, right? In this case, the area is equal to the length, x plus 10, times the width, x plus 1. All right, try that on your own right now. You can stack these things up, you can make a lattice, or you can just look at it and see if you can FOIL it in your head. Stop the video, pause it right here, and see how to do it. See what you get. All right, so let's see how you did. Me personally, I would FOIL this, but we'll FOIL it to check our work. How's that? So let's lattice this. And that gives me an x and a plus 10, and an x and a plus 1, 10x plus 10, x squared plus an x. That gives me x squared plus 11x plus 10 square feet. Yeah, I bet you forgot the square feet, huh? Just because we're talking weird measurements with variables and binomials and so forth, it's still also feet times feet, square feet. All right, if I look at this and FOIL it, I go first times first, x squared, outer 1x, inner 10x, 1 plus 10 plus 11x, 10 times 1 plus 10 square feet. What do you know? Same answer. But totally up to you how you want to do it, all right? But if it gives you units in the problem, you better have units in your answer. All right. All right, so your choice of how you do this, but I do want to see your work on this stuff, all right? Regardless of how you do it. Even if you just stare at it and write down the correct answer, all right? And I'll know you did it by FOIL. Otherwise, I want to see stacking, I want to see lattice, or I want to see the two inner terms when you FOIL it, all right? So lesson 92, A to K and 7 to 8. And you're well on your way towards 8th grade math.